Thank you very much indeed, Tony. That was a brilliant exposition. Everyone else is muted, so you won't be able to hear the applause, but we'll have the opportunity at the end of the evening, I'm absolutely sure. Just to remind people what happens next, first of all, there will be a short take on what Tony has said from each of our three panellists after I've introduced them. And then the floor will be open to Q&A from anyone in the room. But I'd like to begin by introducing our three panellists who all in turn will join Tony in responding to the questions. Our first is Aldermanic Sheriff Michael Mainelli. Michael's a chartered certified accountant, not sure what came first. He's a computer specialist, securities professional and management consultant, and non-exec director of the UK Accreditation Service, where he's a proponent for competitive standards markets, and in non-exec of two AIM-listed companies, as well as being a fellow and trustee of Gresham College and a former visiting professor of the London School of Economics. He was master of the Worshipful Company of World Traders 2017-18, and was elected Sheriff of the City of London 24th of June 2019, assuming office in September that year, but was re-elected for a second year in office just last week, I think, Michael. So congratulations, Michael, a very rare distinction. The Lord Mayor and the two sheriffs are continuing for a second year. Second panellist is John Lockhart. John is chair of the Energy Research Partnership and was formerly executive director of UK Energy Research Centre, who was appointed as the UK's focal point contact for China in the area of energy and renewables for a couple of years. And in October 2014, John was appointed Chief Scientific Advisor to DEC, Department of Energy and Climate Change, as it was, later being rolled into BEIS, where he now works to ensure the department's policies and operations and contributions to wider government issues are underpinned by the best science and engineering advice available. And thirdly, Professor David Orr. David has held senior leadership roles in Rolls-Royce Nuclear for more than 20 years. In the more recent years, led their initiative in commercial power reactors and the UK Small Modular Reactor Consortium. And he was instrumental in taking this idea from a concept into a development programme and gaining UK government support for this strategically very important major development programme. Now director of DLO Consulting, and continues as an advisor to Rolls-Royce on nuclear matters, as well as being a visiting professor at the University of Derby. Now, you could not assemble a more informed panel than the one I've just described. So, gentlemen, if I could ask you to take 2 to 3 minutes each or thereabouts to respond to Tony's talk and introduce your own take, beginning with Michael.
Well, thank you very much, Master, and thank you very much for hosting this. You may have a nice panel, but you couldn't be talking against a better talk. Well, my sincere congratulations, Tony. You've really laid things out very clearly and elegantly. Master, it is interesting that I have been asked to do another extra year. It's the first time since 1228, believe it or not, that the sheriffs have rolled over. But deep in my distant past, in fact, I'm originally a scientist, and my PhD is in statistics. And actually for a period of about 6 years, I was running about 40% of UK government R&D. So I hope I bridge a little bit of the economics and the science. I'd like to divide my remarks up and furiously scribbling if I might. A reminder, as you're trying to make sure that this has a city focus, that the city has been behind the green. I'd like to talk about the targets again. Brush lightly on the technologies, and then close on policy and economics. On the city, just many of you may not be aware that after the Great Smog of 1952, in fact, it was the city that initiated the first Clean Air Act in 1953, leading to the 1956 Clean Air Act. Carbon trading, a number of us in the city, myself included, in the late 90s, took Kyoto seriously and created the carbon trading markets across Europe by basing them here in the city under English law. There was, of course, the Great London Accord in the 2000s, when we had hundreds of researchers looking at the investability of climate change before the Stern Review. And most recently, of course, we have the Green Finance Initiative and Institute. So the city takes this seriously. And amongst the 340 local authorities of the United Kingdom, we've published, I believe, the only credible actual net zero plan. We've avoided the idea of a climate emergency. We see this as a 30-year program that just needs good, hard, solid work. On the targets, Tony remarked quite clearly that it changes everything, this net zero. I would argue now it gets hard. In 1990, I was privatizing 2 of the 12 regional electricity companies, Norweb and Southern. And during the course of that, we had to create the electricity pool. We put forward to the government 2 elements. One was the current spot market, but we also wanted to have a baseload market, a requirement that a regional electricity company could prove that it had baseload capacity, say, for the following 2 years at, say, 75% of the capacity. This would have, in our opinion, created a proper baseload market and also would have encouraged an appropriate storage market. The government didn't like that because it was too complicated. Now, the reason I raise this is that the UK tends to pat itself on the back that we've been achieving or reducing our carbon emissions in the energy sector. And Tony's absolutely right. Energy was highest of the 4 major areas, which is basically energy, transportation, business, and residential. And now it's second to transportation, which one would say is a great achievement. In reality, a lot of this is just due to the dash to gas. And we've probably done about as much in that as we can. Remember as well that our original target prior to net zero was 80% by 2050. We had divided that into 5-year periods. The 4th 5-year period is due to begin in 2023, and we were nowhere close to achieving the 80%. So this is a seriously demanding target that we haven't taken very seriously. We've been taking credits, I would argue, for accident. And finally, on targets, net zero sounds really great, but the urgency is still there because the temperatures, according to the models, will continue to rise after 2050. This doesn't solve the problem in the near term. It's just the way to get it going over the longer. On technologies, Tony's laid them out, but I might make a few observations. You might ask yourself, who is already net zero? Well, there are 2 countries, Bhutan and Suriname. So if you wish to run a country on subsistence, that's great. But we do clearly need to get going. And I think the other thing, too, to echo William Gibson, who famously remarked that the future is already here, it's just unevenly distributed. In 30 years, we can't be counting on magic bullets. Fusion is not going to come in from left field to save us. If it does, great. But our planning has to be based effectively on technologies that we can see and touch today. And in fact, in some areas, we can look around the world, as Gibson remarked. One example, we won't have time to go through these, but one example would be Sweden, where in the residential area in 1990, they made an intense move to district heating and have actually brought the fossil fuels in residential heating down to below 5% of the heating capacity in Sweden. So there are examples out there to learn from, and I think what Tony and his team have done is very, very good. So let's just turn finally, if we might, to policy and economics. And I think this is the ignored area. It's very easy for engineers and scientists to design ideal systems, but across a large economy, unless you believe in Soviet planning, it isn't going to work that way. And the only way to achieve that is to harness technology with the economics. The estimate that Tony put forward of $1 trillion against a $2.85 trillion UK economy, 2,200 billion pounds, is broadly right. It aligns with a number of other estimates that you can brush at. These are all estimates, as Tony indicated, and the models are models and subject to the variables. Another way of looking at it, Imperial College puts forward, it's about 2% of GDP per annum. You might say, well, given the scale of the emergency, 2% of GDP, about equivalent to the defense budget, so not a particular problem. But it is, in fact, a horrific change in some areas. I will give you one example, which is that to make people drive less in America, the price elasticity is really high. So it was in 2001. Americans drove 44% fewer miles. Getting my numbers backwards. Drove 4% fewer miles, and it wasn't because they were listening to the Sierra Club for the first time. It was because, in fact, the price of petrol had risen by 32%. So if you're going to see these huge changes, you need to see huge behavioral impetus from the economics behind it. And I think there are three areas I would point to as areas we might want to look at, and I'll quit. The first is merely to echo what Tony said. We have to figure out how to make this baseload market work. Personally, I don't think it does actually have to be owned by the government, but there needs to be a functioning return to whomever is providing that baseload capacity. The second thing is we have to figure out what we're going to do about carbon emissions. We are only in the European emission trading system until this January, when suddenly we magically disappear without a solution. And finally, legally binding is sweet. It's very, very nice. It's cute. It's the law. There's only one small problem. What is really binding with a government that has repeatedly broken its promises? So it comes, I invest against this billions as a business person. It gets to 2050 and it's not net zero. The government takes itself out back and slaps itself on the wrist and says, naughty government. So one of the things we're looking at in the city is pushing the idea of policy performance bonds, requiring the government to pay more interest on bonds if it fails to meet the net zero target along the course of it. I'll pause there because I've spoken too long, but thank you so much for this opportunity.
Michael, thank you very much indeed. Let's turn to John now to add his take to what's been said already.
Thank you very much,
John.
Master. Let me add my congratulations to Tony for a very comprehensive overview, I thought. I'll just really be brief and just raise a few points that I think is fairly key from my point of view. The first is, as Tony hinted at, I think in this challenge, urgency is probably the key word. Because ultimately we have to make change in an infrastructure that's taken us somewhere between 60 and 100 years to develop. And we've got to completely implement that within 30 years if we're to meet the challenge that we have. And as one instance, we spoke briefly about heat pumps as a possible means of providing heating to our housing. If we're going to do that, much of our housing needs substantially renovating. And when you look at the numbers, we're going to need to renovate about 1 million houses a year to get them to the point where they could take heat pumps. Now, of course, they won't all use heat pumps, but that's the scale of the problem. If we are going to use heat pumps, the second point I'd like to introduce and come back to at the end is the social acceptance of heat pumps. We all are culturally accustomed to point sources of high temperature heat that we can control instantly, and sometimes we even gather around them. If we are going to develop this totally different way of approaching it, to what extent will the population at large actually be willing to play into that field? And how will they cope with the other systemic changes that are needed in the housing? The next point I'd like to just cover is, Tony did a very impressive collection of looking at some of the costs of systems, but I think we need to remember in this that this is an integrated system of systems. We talked about electricity and heating, but it's also a question of the cost of the transport system, the cost of the industrial system, the cost of the agricultural system, and how these things interact. And so I think we can sometimes mislead ourselves in looking at analyses that tend to focus upon one aspect of a subsystem of that without looking at the implications of everything else. And that's not to cast any kind of aspersion on the very useful figures that Tony presented on storage. But one question that came to mind with storage, we tend to focus on the cost of energy stored when we look at the overall impact on storage on energy systems. But in fact, most of the time, it's controlled by the peak amount of power that you need to supply through that system, because that's the dominant factor in ensuring the stability of what happens. I think the two other things I would like to bring up, and that is that we've looked a lot at where we need to be in 2050. That's 30 years hence. If I look back 30 years to 1990, today's world is not what we thought it would be in 1990. And I'm equally confident that the world of 2050 will not be the world that we paint in what are scenarios here. So I think the other factor that we need to look at from engineering is how do we get on with this urgent task that we have to start quickly, but build in the agility to respond to the inevitable changes that will occur as we go forward. And then my final point, and the one I personally think is most important, everything we have done so far has been done by those that operate central supply systems. They have made electricity cleaner. They may have made it more expensive, but they've made it cleaner. Our emissions have gone down. But I, as a member of the public, have had to do nothing different to what I've always done. I've switched the switch on, everything's come out of the wall. If we look at these new interventions, this is going to need individuals to actually change what they do. They're going to need to heat their houses differently. They're going to need to cook differently. They'll need to travel differently. They'll need to buy different products. They'll need to buy different food. So my question about this is, as we engineer the system, how do we engineer the population?
Thank you, John. And finally, David.
Yeah, I'd just like to add the thanks of the other two panellists to Tony's presentation, which was extremely comprehensive. We in engineering, and a lot of you know this, is there's a valley of death between technology readiness levels and manufacturing capability readiness levels, where it takes quite a push to get it over there, and probably some help and assistance as well. The same's true for the economics, and I'm struck by what the Sheriff was saying, because there's no doubt that the capital development that goes on is time sensitive. I mean, there's a good reason why closed cycle gas turbine plants popular and offshore wind's popular, because they can be deployed in a quick manner and returns on the capital investment are short term. So again, if we're going to have an integrated system, not all will be the same, and the interventions will have to be made at different points on timing. Sorry about that. That was Siri, I think, who picked it up on one of my things. The next one for me is the storage and infrastructure as well, because John Loughhead's absolutely right. It's a system of systems, so you can't take the energy production in its own right. Tony got it perfectly well that the actual grid is one of the smaller parts of what we've got to do. There's got to be a lot of synthetic fuel, hydrogen production, heating differences. And again, John, I'm fully on board with, because one of the things that we've been clear about is social acceptance. Because I've been dealing with the nuclear side, we're very sensitive to that. But we shouldn't consider it as a national issue. You have to be very careful with that as well. Because the Teesside Development Authority, for example, when asked about social acceptance by a professor from Surrey University, and said, "You'll never get it," and the lady there said, "Well, we'll have 4 SMRs," and the reason is the AGR stations at Hartlepool give them 2/3 of the local value. So it's not necessarily, it's a national issue in terms of what we're all trying to achieve and strive to. I think social acceptance quite often is driven to major polls across the country, and there are some very localised effects on those. The last thing I wanted to raise really was policy frameworks and enablers, because in the absence of the capital market, then you've actually got to have government policy as enablers. And unfortunately, prior to this government for 13 years, I don't think we've had a government that's had a strong enough majority to do much. So that's a huge risk to all this. So for me, I don't know how you get to the legal bit when you haven't got a government. Over the past 20 years, we've probably had only about 40% of the government that can make any decisions. And I think that's one of the massive risks that we've got to this whole endeavour. Thank you.
Thank you very much, David, indeed. Now it's turn for you to participate as the questioners. And if you could identify the preferred respondent to your question. That would actually help us allocate between the panelists, but everyone will obviously have an opportunity to respond to any question. But it would be good to get the maximum number of questions asked, so we may restrict the answers to just the one in each case, in some cases. And an advance warning, in true livery company, we will finish at 8 o'clock with a toast you may wish to prepare for that particular moment. I am already prepared. So could I hand over to Clark David to take us through the Q&A and ask the first, at least as far as you can make out from the combination of chat and blue hands, who was the first to pose a question? David.
Master, thank you. I think our first questioner is John Chandler, who I'll just unmute. John.
Thank you, Tony. That was the question's for you. That was a really interesting presentation and very clearly put. Thank you. My question really is on the demand side. You focused a lot, quite rightly, on the supply side, but on demand side, we are going to be using, in some areas, certainly, surely a lot less energy. Everything is driving to be more energy efficient. So how much work's been done on assumptions there? Because the two have got to meet in the middle, haven't they?
I'll try and answer this. It's probably, John Lockhart probably has better knowledge than I have, but there are a number of estimates out there from a low electricity demand to a high electricity demand. And the National Grid have looked at 2050 and published their future energy scenarios, and they're in the low electricity, slightly higher gas at about 500 terawatt hours. And then other people, some of the work done by Imperial College and some of the work done by UCL are more at the high end, in the region of 750 terawatt hours, because they depend more on electricity in the heat system, and this requires more in electricity. If you look in the Climate Change Committee's report, they go for a central 600, but they have ranges of electricity demand which go up to 1,000 terawatt hours. Now, as I understand it, all these estimates include substantial energy savings. And the main effect for increased electricity is moving demands which are currently not electricity, like electric vehicles or hydrogen production or some heating, to electricity. And the consensus seems to be that even with strong action in energy saving, we will have perhaps twice the amount of electricity in our system in the future.
Okay, thank you.
And John, do you want to add to that? John has to leave a little bit early, so we'll use every opportunity to bring him into the answers.
Thank you, Master. Tony's absolutely right in that. There are lots of assumptions, but I think that it's really important to bear in mind the fact that these are assumptions based upon projections into the future. And that's why I made the point about agility, not to say any of them are wrong, but there are inbuilt assumptions about reductions in energy consumption which go into that, which are based upon projection improvements in systems. But the irony is that I sort of ask you to bear in mind is that although we don't think of it this way, the world is not short of energy. We are actually awash with energy. There are tankers full of the stuff parked outside our ports trying to find a market. We've got lots of solar energy. So one of the issues is not about the energy, it's about the impact on the environment or the cost of the infrastructure to be able to access it, which will be the determinant factor. So our concern with energy efficiency may be a reflection of our 1970s education.
Interesting.
Well, our next question, could we have Rick Parker? I'll just unmute.
Yes, Tony, thank you. It was excellent talk and very explicit. A quick comment and then a question. The comment was on the Prime Minister's announcement today, and I think you adequately debunked that, this idea that an extra 30 megawatts will somehow get us over the, gigawatts will get us over the line by 2050 to be totally dependent on wind power. It is a nonsense, and it needs much more than that. And the availability of wind, I mean, the other thing I think you made very strongly is that it's not the power generation that matters, it's the amount of energy we have. And for a given gigawatt in wind, you only finish up with 30% of that over time as energy due to the wind not blowing, due to mechanical failure of windmills, and due to scheduled maintenance. So, you know, the Prime Minister clearly got to something, been ill-advised. If I can ask a more specific question, though, back to your alma mater and nuclear, I think, again, you made a strong case that part of the base load for the future does need to be nuclear. And that last graph you put up shows it's possibly affordable, which isn't the popular view at the moment, when you take into account the cost of storage for other intermittent sources. What you didn't mention, this challenge of where we're going to get our heat from, particularly for industrial processes, maybe even for producing carbon, hydrogen. What about directly using the process heat from nuclear power stations rather wastefully turning it into electricity and then turning it back into heat again? You certainly could do the steam reformation of methane directly in the nuclear power station using clean heat. You've still got to get rid of the CO2, as you say. But you also could just put your cement factories and your glass factories and your steel works alongside your nuclear power station, or vice versa.
Well, perhaps I will try and answer that last question. There clearly are nuclear technologies around that can produce the sort of temperatures you're talking about, high temperature gas reactors and such like. However, they aren't the things which are, if you like, use that terrible from shovel ready at the moment. They are part of this class of advanced reactors, which, having stopped doing research in the UK for the last 20 years, we're slowly starting to think about molten salt reactors, fast sodium cooled fast reactors, high temperature gas reactors. And there's beginnings of also work in the US and in Canada. I think these solutions could play a part in this, and I think the Royal Society is producing a paper on this exact point. It's in front of the storage one for issue. The problem is that the nuclear technologies need to be developed and deployed for some other use before they come for industrial, because the cost needs to amortize over a very big use like electricity. And if you look at the timescales of their demonstration and prototyping before they can be commercialized so that they be produced in numbers, they fall in the timescale which is a little bit beyond what we see. I know there are some enthusiasts promoting these things, but anybody who's been in the industry a while will say that even with a firm commitment and heaps of money, seeing the commercialization of a fast reactor or a molten salt reactor before 2040 is quite difficult. I think you covered the business about the availability and the fact that you need quite a lot of gigawatts to get the terawatt hours from wind, and particularly from solar, where the availability is about 11%. So 100 gigawatts of solar doesn't produce very many terawatt hours.
And David, anything to add to Tony's reply there? Not that you probably could add to that excellent reply.
No, it's very good. I mean, by the time you've obviously used the heat for your steam turbine in a pressurised water reactor, the actual exit temperatures are pretty low. I mean, you can use it for district heat systems, but Tony's absolutely right with just about everything he said. It hasn't been raised yet, but if you don't mind, I was remiss not to raise it in my summary, and I will. I'll take the opportunity quickly. Is that the national grid have an awful lot of parameters to manage for stability of the grid. Tony did mention it in passing in terms of having rotating machinery on the grid. Synchronization and frequency of grids is massively important. So it's not just the actual power availability and the power level. You've got the current, the voltage, you've got the frequency, you've got synchronization as well as power level. And there are a few more that the national grid operators who we've spoken to tell us about. And it is a huge issue, because the last time we had a major outage in the UK, and I'm sure John will correct me if I'm wrong, there was about 1.2 million that were kicked off, and that was exactly about frequency and synchronization of the grid. And the trouble is that when you're looking at renewables and things like interconnected power, they all go through power electronics. So you've no actual mass that's giving you synchronization stability on the grid.
Good. Well, our next question, if I may take it from the chat, is from David Hurst, and it's addressed principally to Tony, but for the panel generally. Do you have any comments or view on the time value of short cycle carbon biomass given the need to reduce CO2 today? The biomass business model depends on the future plant growth to offset CO2 emitted today.
Right. I didn't really cover biomass in detail. It got pushed out. There are limits to biomass. Looks like an attractive thing because it's one of the few things that can have negative emissions and therefore help balance the books. And although it's expensive, it's cheaper than direct air capture. Everybody seems to agree with that. There are limits how much biomass you can grow, whether it's various types of trees and such like. And although there's quite a lot of wood around in the world, I think we're moving to the position where if you import something from somewhere else, then its carbon value will be taken a note of. I mean, most of our biomass at the moment burning we're importing from North America. That if in North America they're counting growing the trees as negative emissions, and if we count it when we import it and burn it as negative emissions, I think this will get found out by the international community. So we probably are limited in real savings for BECCS for the wood and such like we can grow in this country. And so the government said we're going to have many more woods, but I think this is going to limit the availability of the scale of what we can do with BECCS. So BECCS have got an economic problem, but I think they've also got a physical limit in terms of how much we can grow in the UK. I think maybe there's a bit more subtle point behind the question about this as a one-time saving rather than repeated saving. But I think in the simple way, BECCS are going to be limited by how much biomass we can grow in the UK and about economics.
Thanks. And John, I'm conscious it must be close to the end of your designated time. Anything to add before you leave?
No, I think the biomass question is a very interesting one, and it is a very good point about who's going to get the credit for taking the carbon out of the air. Is it going to be the person that grows the plant, or is it going to be the person that burns the plants to create the CO2 to put under the ground? And I think that's a very perceptive question, personally. Just allow me literally 20 seconds going back to the question about nuclear. I think that's really valuable. And I don't believe that we properly thought through those areas in which we can use the energy that nuclear fission releases. And I deliberately said fission because I agree with the earlier comment, leave fusion till sometime towards the end of the century, I think.
John.
Good. Well, our next question, if I may, comes from Will Drury.
Thank you very much. Fantastic talk, Tony. I just wonder, you talked about, do we have an opportunity or is this a problem before us? Do you see, actually, if we go back and really look at this, maybe it's something that we could start to rebuild our supply chains in this country. We've offshored so much technology, we've developed it here, and then it's made abroad. Should we be looking at this in an even bigger way and going, we need to look at reshoring a good number of our power electronic machine drives and these type of reactor technologies to the UK to not just make us net but grow back our economy?
I'll have a quick go, but I'm sure other people have a view on this. Having talked to some of the climate change people, they think we've missed the boat on producing solar panels and windmills in the UK, but we haven't missed the boat on hydrogen economy. If we go for a hydrogen economy, there's plenty of scope in the electrolyzers, in the fuel cells, and the storage technology. And this is quite a new area, and you have to get in at an early stage. So I know Julia King is very Baroness Brown is very keen that we perhaps have an opportunity in hydrogen to get a lead and to get ahead. That in the nuclear space, which I know quite a lot about and I've taken an interest in, but I'll let David talk about, is that SMRs maybe provide an opportunity for us to get back to something which would be useful in the UK and maybe even useful for export.
And this may be one that Michael would like to come in on, because very much an issue of UK PLC concerned here.
Yes, thank you, Master. And Will, an excellent question, and one I think that doesn't have a straight answer. This is going to sound a bit peculiar, but we have a history of every time we have a government policy in a sector, we lose that sector. And I would refer you to things like the ALBI programs in the 80s. I would refer you to Marconi and the electronics. I would refer you to British Leyland, all of which I actually worked with. So it's a very depressing thing when we try and have a government managed sector. Does that mean we can't have a major part to play? Most certainly, and I agree with Tony. Hydrogen is just gaping. It's the goal. It's the goal to go for. But I think it's the way that we go about it. And in a highly centralized country, we've lost over the last half century, in my opinion, the ability to just let it roll. Because to own these sectors is to take a lot of risks, and this means failure. And it's extremely difficult in a centralized country to say, I spent a few billion on hydrogen, and you know what? Most of it flopped because it's called research. If we knew what we were doing, we wouldn't be doing it. And the two things that lead to huge bursts of innovation leading to industrialization tend to be one, bubbles. Bubbles. We got very little out of the dot-com bubble in the United Kingdom, but we did get a little bit. But the huge wastage that results from it. And the second one is, of course, sadly, war. Now we've got this lovely target that's driving us in a slightly new direction, trying to force us effectively to have a bubble. But will we respect the fact that to make that bubble work and to get those technologies, we're going to have a lot of failure? And that I'm concerned about.
I think that's interesting, Mike. You used the word failure, and that's a very British way of looking at it from all the people in Silicon Valley I've worked with.
Yeah,
that's a lot of learning.
It's a lot of learning, but it's but translated into public policy terms is failure.
Absolutely.
And yes. that's the difficulty. How do we change that narrative? Thank you.
Yeah, thank you.
Well, if I can go for our next question, back to the chat. Tim Gammons posed one for the panel at large, in saying, one of John's responses was to raise what appetite do citizens have to change behaviours? As engineers, we like to provide solutions to match problems, i.e. citizen demand. Should we engineer a communication strategy to reduce demand?
Well, I'll kick in here, and personally, we have that communications strategy. It's called price, and if we can actually embed these costs in it, then that's what will lead to the behavioral changes. We've already seen that the behavioral changes forced upon us by COVID have dropped demand by, depending on the estimates, I'm not quite up to date, 6 or 7%. So you're not going to get to net zero that way. It will definitely be a help. A lot of things you can do. We can say, well, I travel less, I'll turn my heating down, I'll wear more jumpers, a lot of stuff like that. But it won't get you to net zero in the type of lifestyle which we're currently saying we'd like to maintain. Hence my point about Bhutan and Suriname.
Yeah, if I can just add to that, I think when we've been doing our developments, we've had polls done, polls on acceptance, and there are two things that the general public worry about. One is what the cost of their heat and electricity is, and the other one is security of supply. And I think if you cover those two, you'll cover about 70% of the population. Sure, when you're getting into some of the other things that we're talking about, because it isn't just nuclear. I mean, we all know that lithium ion's not very good for life cycle management. Neither are some of the chemicals we're talking about in the processes to produce hydrogen and carbon free. So There has got to be a fair bit, and I don't underestimate this, of social acceptance. And we tend to have streams on that. But I'm afraid it's not my particular forte as an engineer to do social acceptance, I'm afraid.
We usually need some help in that regard. Yes, absolutely.
We do,
Teamwork.
yeah.
Teamwork. Next question, David.
John Chandler's got his hand up, but if I could just go to another chat question from Neil Glover, it's on the price matter that Sheriff Michael just mentioned. How much will each energy system require in terms of raw materials, and also who controls it? The materials used for batteries are located in a limited numbers of countries around the world: lithium in Peru, Argentina, Australia and China, cobalt in the Congo. What does this do to economic and political stability? We have seen the power exerted by Saudi Arabia using oil, and now the political pressure exerted by Russia on Germany because it supplies gas. Other energy systems also consume resources. Any comments on price stability versus absolute price?
Definitely Michael's question.
Yeah, it's a really good question. It's one with a lot of detail in it, and I don't have it to my fingertips, but I'll make a couple of remarks. I mean, one of the problems in the debate on the rare metals is the assumption that they're rare. They're not rare. They're actually rather common in many cases. However, what is rare is an economic development at the current price, and that's what's driving you to places like the Congo or China. China has kept its supplies open. I say that as somebody who's actually bought and sold some tungsten mines in China, so I happen to know a little bit about it. They have seen it as a strategic resource and therefore kept it open, and the supplies are theirs. We could open such resources. Anyway, that's the first element, and probably ought to be thinking about that to reduce some of that volatility. And the second thing that comes back into this is, again, price. As the prices of those metals rise, we are finding people looking and exploring in Canada and America and other places to open new mines in areas, again, like cobalt. Lithium is actually rather common, etc. So we're finding basically the price is beginning to change that. But this is, again, where you need the consistency of a policy. So if you're going along a certain technological path that requires a certain rare material, are you going to dig a mine if you think that policy might change tomorrow? You want to see that that's a 30-year policy, so it justifies the investment required to dig a deep mine.
I'll give my similar answer to that. From the nuclear industry, people built the case for fast reactors on the fact that uranium was scarce. It's not scarce. We haven't looked enough places at what price. When people start looking at it, uranium's not scarce. People say that for batteries, lithium is scarce, and it's largely because people haven't looked at it. I mean, you've seen in the press, people said if you look down tin mines in Cornwall, it has lithium-rich water coming out of the mines. I'm not sure whether that's an economic proposal. It's just people haven't looked. And once the price signal goes there and people look, I'm a real skeptic about these strategic materials are not available.
Good. Well, if we now come to John Chandler. John, unmute you.
Thank you for a second bite. Where do you? I've been interested in your views on where you think the current natural gas network is going to go. Is it going to? Do you think will convert to hydrogen, or actually will it wither on the vine, and the end user will be electric only?
Right, I'll stick my neck out, but it's an opinion. There's a big investment, both investment in the ground and by the old companies in this gas grid network, and they will want to make it cost. So I think that's quite positive, and it's because of that I think there'll be a big push towards blue hydrogen rather than green hydrogen, though probably we should for green hydrogen. I just point to there's been quite a big study in detail about what would have to be done to make a whole city go hydrogen rich, done around Leeds, and it's done many levels, being paid for by BEIS, about the supply from the national grid, the local infrastructure needs improving, what needs to be going to each house, what applicants application changes need to be in the house, how many people are required and how many fitters are required to convert a city the size of Leeds. And this report is a very substantial report, and it shows the focus and the push that's behind using gas as a means. I think that while you can make arguments about heat pumps or gas, we probably will end up with some mixture of the two, and therefore the gas grid will be used. And so that's my opinion. I think the gas grid will be used, and we will use gas. The question more is about whether it's going to be green hydrogen or blue hydrogen.
Okay.
Can I just add a little point on that as well, because it was raised by Tony, but not very forcefully, because he was covering so much. But what absolutely shocked me when I looked into it was that currently in the UK, and probably not just the UK, the housing stock, when a new design is made, they pass the efficiency at the design stage only, and it's never tested. So like in the majority of what we consider is verification and validation to prove what you've designed, they just don't do that in housing. You see the odd one on Channel 4's programme, but that's the complete rarity where you have online monitoring of housing efficiency. It just isn't there. And the houses are far from the design stated efficiency, probably less than 30% of what they've been designed to. So, I mean, all that needs tightening up as well strongly to reduce the amount of demand. But again, it's a lot of money, you know, it's going to make housing more expensive. So there's going to be trade-offs with all these things.
If I might kick in and underscore David's point, there is no really back testing. And this brought down the Green New Deal. A number of us pointed out that the numbers being provided by the Building Research Establishment in advance of the Green New Deal had outrageous assumptions on the amount of energy that would be saved. And that's what brought it crashing to a halt, was actually bad input numbers, the government genuinely believing what it was being told by the industry, which had never really been back tested.
Okay, from the chat, there's one from Mike Middleton, if I may put that to you. I know Rick Parker's already commented on it, but for the panel, is there a view on the potential value of clean synthetic fuels in achieving net zero? Can they aid decarbonising really difficult fossil fuel applications? And can the production of synthetic fuels be a contributor to economic growth? Could their selection and use by consumers be promoted as behavioural change?
Yeah, I can start that, I think, and then I'll let the others sort of jump in. We as a company have worked with the oil majors in the lines on this, because although hydrogen, electric and hybrid are fine for aircraft flights up to about 1,000 nautical miles, so you're talking about broadly Europe and perhaps Turkey and Greece. But that's about all. If you're talking about long-haul or transatlantic flights, it just doesn't have the power density. So, and that's true of hydrogen as well. Effectively, you have to have synthetic fuel. And Jet A, kerosene at the moment, is a significant contributor to the carbon emissions of the country, because they actually do it from the originating planes for its full destination. For those of you who doubt this, another amazing statistic is that a transatlantic flight from Heathrow to New York takes the equivalent of 350 megawatts of power, and that's just one way. So the amount of carbon that's coming out of pure kerosene in those is massive. Decarbonising is a big option. The other thing is, unfortunately, it's likely to drive up air costs, because it is going to be done. It's being done now. I know they're doing it in California, but what they're doing is they're doing a mix. So they're starting off with a proportion of synthetic fuel to kerosene and things of that nature. So it's not necessarily an overnight thing, but believe you me, our air travel is going to be more expensive in the future, whichever way you look at it. Not that if we start with these pandemics, we won't be flying very many places anyway, but it is going to be a lot more expensive to fly. The other point is the same goes, because if you can do synthetic fuel for airlines, then you can do it for cars or any other internal combustion engine as well. It comes back to economics again and price point, and unfortunately, it'll end up being twice the cost, at least. So, and that's with efficiency improvements as well.
Just perhaps add a little bit to that. We've looked at it as part of the energy storage, because instead of storing hydrogen or ammonia, you might store synthetic fuels. The problem with hydrogen is keeping it in the bottle, whereas if you have a liquid, it's easy to keep in the bottle. If you look at the number of transformation, basically synthetic fuels are taking energy from some other source and putting it back into a hydrocarbon form. Because it's reversing the thermodynamics, whatever improvements you might get, there are physical limits to do with the thermodynamics of making the constituents and then forcing them together so into synthetic fuel to be used. And so I'm sure that there are whatever measures you have at the moment of the cost of synthetic fuels, they can be brought down, but they cannot be brought down substantially. They'll always be related to the source of the fuel, whether it's renewables or whatever. Whatever the source of the fuel will then have enough multiples to do with these thermodynamic transformations. That we decided for storage that it seems to be a non-runner because of these thermodynamics, and it's worse than ammonia, and ammonia is much worse than hydrogen. So that's where you stick, and therefore it will only be used in these niche areas where there is no alternative, and perhaps aerospace is either one or the one. Of course, the other use for this type of technology is, we do have plastics. Plastics require energy. If we're using oil for it, effectively that's another use of synthetic fuels. So it does have a place, definitely has a place, but it's at a price.
David, that may have been the last question, do you think, David? Or could we
have
squeeze another one in?
One last one on the chat, if I may, and then we'll call it a day. It's from Pastmaster David Johnson. The current gas grid doesn't serve significant parts of the country where there is a reliance on oil. There is also a paucity of electricity grid in these areas, evidenced by frequent brownouts. What is the view about removing reliance on oil in rural areas?
Yes. Well, I mean, what is said is absolutely right. We're talking about the structure of the system, and there will always be extremely difficult positions. This is why I think we may make a broad decision about heat pumps and gas, but it won't be a complete one. I mean, in parts, I think there's something like 10% of the electricity use in the UK is resistive heating in places where there's no gas grid and people don't want to burn oil. I mean, it's the worst type of heating you can imagine. But already at the moment, that's what we have. And this will persist because people are not going to extend the gas grid to everywhere. So for those ones, either direct electric heating, which would be terrible, or heat pumps, or some sort of assisted heat pumps, will become the answer. And we will need, as well as these big answers to the standard problem, we'll need a peripheral range of ones which are answers to the particular problem and the diversity problem. And it's just another example about how far we're going to go. If we're going to do 27 million homes, we can design systems which might together do 22 or 24 million of these things, but there's going to be lots and lots of specials for the others, and they all need to be addressed if we're going to get to net zero for the whole economy.
I mean, one of the things we can do as well is we didn't talk much about microgrids. I mean, there is we talk about the national grid for many applications, but microgrids and the cost significantly. So I don't know if you could form cooperatives to do something of that nature at a local level as well. There are various solutions that you can do. Fuel cells are coming down in cost and reformers now as well. So there are different solutions, but I feel your pain because I've got a big green gnome as well in my back garden.
So we don't have to depopulate the Western Isles just yet, then, David. That's good to know. Michael, any final words from yourself? That's the last of the question opportunities.
Just make two remarks, about where we might have taken this. I mean, one is when we're looking at the benefits. This last question from Ben actually makes an interesting subtle point, and that's that the increasing resilience and reduction in volatility is something that actually ought to be valued in some of this, as we're injecting a much more complex system, which is hopefully more adaptive. And I think the other thing is that the timeframes and the policies that we're doing might be counter to each other. So, for example, the government's declaration of no petrol vehicles in 2035 pretty much obviates the use of hydrogen because we just don't have the time to get it out there. Therefore, sort of countering Will's earlier question about, can we own this market? So sometimes you're closing down options too early that the market ought to handle. And just a very final point, also related to that last question, but time and again, an insight that somebody gave me years ago is that the only difference between renewables and fossil fuels is embedded storage. An oil drum full of oil can sit in the corner for a few more million years. Well, it'll probably rust away first, but renewables dissipate immediately. And I keep coming back to storage, and I think where Tony's got some really good points on this is about the importance of hydrogen and the fact that it helps to solve that storage problem. Thank you, Master.
Thank you, Michael. Fascinating, everyone. Isn't it wonderful when you get expertise in the Zoom room of the quality that we've had this evening from Tony and our three panelists, Michael, John, who's had to leave, and David. It's absolutely fascinating evening, and deep knowledge needs to be respected. And I hope, Tony, that you and the Royal Society group are being heard by government, and that you do have your PR gurus sitting alongside you if we as engineers can't be trusted to communicate to politicians. But the combination actually of engineers, politicians and financiers is a very powerful trilogy, and if we get all three with the same vision, then we can pretty much, I think, tackle any existential challenge. And maybe we can take some hope from history, unless you're a dinosaur, of course. They faced an existential challenge and became extinct. But London in 1349 or thereabouts was facing one with the Black Death. And people at that time must have thought that was it. There was such a high fatality rate, up to 80% in cities like London. But they survived, and recovered actually quite quickly. Dick Whittington was mayor only 50 years later. The 1858, London had the year of the Great Stink, when MPs were fainting in the House of Commons. And London was the first large city. It was the largest by far in the world at the time, but it looked like it was a failed experiment because it was unsustainable. It was unhealthy. People were dying of cholera and typhus. But then, with a massive injection of finance and engineering, an infrastructure-led solution with Bazalgette rescued the city, the idea of the city as a concept, you could argue, and London moved on. Whether COVID-19 is an existential challenge or not, time will tell. Let's hope not. But climate change is for sure why we're talking about net zero right now. And the parallel from 1858 is anything to go by. A combination of finance, politicians with vision, and engineering are our best bet at getting there. And I think we've heard a lot of that this evening from a combination of our speakers and our panelists. So could we all collectively thank Tony, David, Michael and John for such a superb evening, dealing with the Q&A session so effectively. And normally, of course, I would say safe home at this point in time, but you probably all are already.